Hi everyone, this is Cameron. Today I'm going to demo my new desktop application, speech-to-command, with its Vim library to write code by voice. Afterwards, I'll demonstrate how it works and the architecture of the code. And for the sake of the demo, I'll just be showcasing random navigation and dictation commands. So I'm going to start by turning on speech recognition. "35 teleport below, case valley quote hello quote valley colon valley, retreat, insert colon valley, result capital found capital equals true semicolon, type no problem parents, quote hello quote right after semicolon, comment, prequel indent, nuclear, shave, below, print, erase, reset, print, quote hello, jump after semicolon, prequel jump, insert, nuclear, "9 teleport, insert, public valley class valley hello brackets, infiltrate, down visual, 2 up, delete, down, subsequent change, beast, retreat, normal retreat, delete, insert public, 16 teleport 4 forward, 2 forward, subsequent change hello, undo. And I also have a library for Windows navigation, which just shows the versatility of the libraries you can create, so I'll just demo some of that. Cambridge, for prequel Cambridge, application, below, spacing. This is a demo of the general dictation, comet, nuclear, okay, that was just a brief little demo of the preloaded commands, and later I'll show you how to write your own libraries and how the code works. Okay, so let's go over the code structure with this code architecture diagram. So red is just the key. Red is a class, blue is a variable, and yellow is a function. So you don't need to worry about this code, but just for your reference, web speech recognition recognizes a word and it sends it to a socket, and the Java desktop application is listening on that socket for the word, and then we handle that word accordingly. So it starts off at the The word starts off with the speechToCommand class, which has two variables, the number precedent and parameter precedent, which are just modifiers for the command. So example, if you wanted to command the program to move four keys to the right, instead of saying the command right 4 times, you could say 4 right, and the 4 would be stored in this number precedent, and the command checks for this to see if a number is stored here, and applies that to the command. Same thing with the parameter precedent. It applies the parameter to the command if applicable. So from the speechToCommand, we have to determine what to do with the word. So we access the classifyWord method of the classifyWord class, and it runs through this if-else structure. So if the word is a number, it stores it in the speechToCommand number precedent variable, and if it's not a number, then we check if it's a parameter, and if so, store it in the parameter precedent variable and break from there. And if it's not a parameter, then we check our grammar libraries. For example, the Vim navigation library that I demonstrated earlier with the navigation commands, that's just one of the grammar libraries. And each grammar library has a command called search for command, where it runs through the list of commands, and if the command is found, it runs that command accordingly, and then it breaks. And if that command is not found, then it runs through the next library and next library. And after all the libraries are iterated through, it goes to general dictation. So general dictation is when you want to print a word, and the word is not reserved by any of the libraries or parameters, or is not a number as well. So the general dictation library has 4 modifying variables to the text. So for example, capital equals false. So if capital is set to be true by voice, then the first word of each word printed would be capitalized. And this is useful for camel printing variables, where you'd say the first word and then say capital and print the second word, so it would be camel cased. Caps lock would turn the whole word capital, and type mode would print the first letter of the word. And actually there's one that's not included, spacing mode, and that just includes a space between each word. So it's as if you're dictating text. So there's a space between each word. So once the word is sent to general dictation, we determine if the word is dictate, which is just turn dictation off, so it won't print the word. And if the word is not dictate, it goes to see if it is a dictation command, which is just one of these variables. If the user is trying to turn one of these variables on or off. And if it's not a dictation command, then we print the word. And like I said earlier, these words are applied as transformations to the word, like capital, caps lock, type mode, and the one that includes spacing. Okay. So the final class that is accessed is the Roboto class, which is essentially a robot that sends the computer keystrokes as if you were typing keys. And it has 3 methods: the type string method, the do type, and PC. So type string is you feed it a string, and it breaks it into a character array and presses the matching key event for each character, as if you're typing that string out. The do type is a method that takes in the parameter of an integer or an integer array. Because key events, you can look up the documentation, but key events are reduced to integer key codes. So it takes in the parameter of integers as key events. For example, to press the up key, you type key event dot vk underscore up. You click up the Java documentation for that though, it's pretty simple. And lastly is the PC method, which takes parameters of a string to type and then an integer array of keys to press. So example, if you wanted to type a string such as brackets and you wanted to then have the cursor move left inside the brackets, you type the string of brackets and then the next parameter is the new integer array of the key event to move left. So for each library, for example, the Vim navigation library, when a command is recognized, the command has a set string to feed to the Roboto class. And the Roboto class types that string out for the user or whatever function is accessed. And that's how this process is applied for each word. And that's how the application works. Okay, so now I'm going to show you how to install and run the speech-to-command program. So first, navigate to the GitHub repository. Username is Cameron O. Smith, and the repo is speech-to-command. Navigate to the release section and download this file. I've already downloaded it. It's right here. And next, we need to run the speech recognition on a server locally because I don't want to pay for hosting. So download XAMPP. You just search download XAMPP, and the first thing is apache-friends.com says download XAMPP, and download the latest version down here. And I've already downloaded and installed it. So let's go to there. So once you've done it, once you've downloaded it, start the Apache server. Now mine is running on port 90 because I had to change it because the port was reserved, but yours will be running on port 80 probably. Navigate to the Explorer, htdocs, go back to the stz zip we downloaded from the release page, and just drag this speech recognition folder into the htdocs, and now execute the Java runnable. Just double click. Now you need to have the Java SDK or the runtime environment rather installed. Most people have that, but if it's not working, you might not have that installed. Okay, so let's verify this is running. Okay. Now let's navigate to localhost 90, or yours is going to be 80, speech recognition. Let's verify it's working. Insert hello. Below, iterate, 2 down below, spacing, and there you have it.